You're welcome to this video. In my last video, I explained the definition of the retrieval augmented generation RAG, as well as the benefits and the application. In this video, we're going to be implementing the RAG technique using three tools: Langchain, OpenAI, and Qdrant. So Qdrant is basically a vector database that we can use to store and retrieve our knowledge base. So let's dive into it, shall we? First things first, we need to install the packages that we're going to make use of. So I'm going to do share mode, pip install quiet mode because I don't want to see the log. Install Langchain, Qdrant, Langchain community, Qdrant client, with the package I'm going to use to communicate with Qdrant directly, and Langchain OpenAI. So using Langchain OpenAI to communicate with OpenAI through Langchain. So let's install the packages. And good, we're done. So another thing we're going to do is to load our file. So I've already prepared the knowledge data that for this blog post that I wrote on LinkedIn. So this is what we're going to be using as our knowledge base. So I'm going to be asking the LLM question based on this context. So this is what we're going to train it with using RAG. So we store this as our knowledge base, and then ask the LLM question based on this context, and let's see what it's going to do. So let's load our file. First things first, before we proceed, we need to ensure that we've set our OpenAI API key, right? And we can check that. Let's import OS. We'll make use of two tools, which are OS and getPass. So getPass is a Python package that you can use to set your password or your secret keys. So let's do that. Yeah, let's check. If not, os.getM OpenAI API key. OS dot everyone OpenAI API key is equal to getPass dot getPass. Enter your OpenAI API key. So if we run this, if you've not set your OpenAI API key, it's going to prompt you that you should enter your OpenAI API key. But if you've set it already, it's going to pass. It's not going to do anything. So let's see. Yeah, so it's asking me to set my OpenAI API key. So I'm going to do that. Let me copy my OpenAI API key, and I'm going to pass it. And I'm going to pass it here. Right. And I'm done setting that. Good. So the next thing I'm going to do is to load the file, our knowledge base file, the PDF. Here, this is the synthetic knowledge, the PDF here. So I'm going to make use of Glob. So Glob is also a Python package that you can use to find all the parts, the 5 parts of all the files on your system. So let's make use of Glob. Right? I can do glob. So find me all the files that ends with a PDF extension using the wildcard. So you can see that it actually loaded. You can see that it actually finds the PDF file. So this is a single PDF file that I have here. So I can do glob. Let me do glob doc to be this, and I know my glob doc is going to be the same thing as that, and I can save it as knowledge file. Knowledge file is equal to glob doc index 0, and if I do my knowledge file, I should see that that's the file path to our knowledge PDF. So I'm going to now load this knowledge PDF into our loader using the PyPDF loader. So Langchain has a PyPDF loader that you can use to load your document. So that's what we're going to make use of. So let's import that. So from Langchain.document loaders, import PyPDF loader. Yes. So let's load. Loader is PyPDF loader. Let's load our knowledge file. This is the file path, and then you can now get our knowledge doc, which is loader dot load, and if we retrieve it, we should see the knowledge of our it has already loaded our knowledge, our contents of our knowledge base file. So let's clear the output. And so for best practices, it's not always good to like load the whole document. You can see the content of the file, right? It's not always the best thing to load the whole content into your vector database. It's always good to split it and to chunk it, right? Especially when you're working with files. You could have a file or a document with many pages, and to load them, the best practice is to always split it into different chunks, and then we can work with that. So that's exactly what we're going to do then. We're going to split the document into different chunks using the text splitter, and then we're going to get the chunks and then store the chunks in our vector database. So I don't want to load, although this file is quite small, but when you have a large file, it's always good to split it. So we're going to split this file into different chunks using a text splitter. Now let's import our text splitter. So we'll make use of Langchain text splitter. So from Langchain of text splitter, import recursive character splitter. So it is recursive character text splitter. So let's split it. Text splitter is recursive character text splitter. and we can pass our chunk size. So I'll set it to 1000 and then chunk overlap to be 50. Yes, so we've created an instance of our text splitter. So the next thing we are going to do is to split our knowledge docs. So let's do knowledge text, which is equal to the instance of our set text, our splitter dot split document. So we can pass our knowledge doc. So if we get the length of our knowledge text, and yeah, see that we have 10 already. So we split it into 10. Yeah, into 10 different chunks. So next thing we're going to do is to create an instance of our embedding. So we're going to be making use of OpenAI embedding. So embedding is a way to convert your file or the context of content of your file or your media into vectors for similarity check. So before we can store it, so this is the flow. You have a document or a media or a file, you convert it to a vector using embedding, and then you now store the output, which is a vector, which is in vectors form, and then you store it in the vector database. And our vector database is Qdrant, like I said earlier. So we're going to be making, OpenAI has an embedding instance. So we're going to be making use of OpenAI embedding instance. So let's import that as well. So we do Langchain, OpenAI dot embedding import OpenAI embedding. Yeah, we've done that, and we set our embedding to be OpenAI embeddings, a module, pass a module to be. So there are different modules for OpenAI embeddings. I'm going to be making use of text embedding 3 large. Text embedding 3 large. Here we go. And let's start our Qdrant. So for your Qdrant, you can decide to use a cloud-based Qdrant, right? You can decide to use a cloud-based Qdrant, or you can set it up locally for this tutorial. For this tutorial, I'm going to be making use of Docker, the Docker version. So I'm going to start the instance on my Docker. So I'll do Docker run this port 6333 and all that. So I'm going to click start and it's going to run. You can see that it's running on port 6333, right? If you go there, we can see our collection. So let's copy the base URL. That's what we're going to make use of for now. So Qdrant, if your own version is the cloud based, just copy you'll be provided a URL, a base URL to access your Qdrant, as you can also input that here. And if you're using a Docker base, you can copy your own on your local host and the port. So this is mine. I'm going to start. I'm going to enter this. Yeah, save that. Then I'm going to create an instance of my Qdrant, the Qdrant client. So, which is going to be from Qdrant client import Qdrant client. From Qdrant client, import Qdrant client. So we've set that. Now let's create an instance of our Qdrant client. Qdrant client is Qdrant client that will pass the URL, which is Qdrant URL. Yes, so I've already created an instance of our Qdrant client. So the next thing I'm going to do is to create our collection name. So collection is basically a group of data that you store in your database, in your vector database. So it can also mean, in the traditional database sense, collection is like a table. It's where you create a table in the traditional database, right? So it's the same thing that we have. We have table in the traditional database, and in Qdrant vector database, we have the collection. So let's set our collection name. Collection name, let's set this as rag vector. Let's set it as rag vector. So we save that. Then let's create our collection. So to create our collection, we'll make use of Qdrant client. So let's do that. Qdrant client dot create collection, and we have collection name to be our collection name, and so we need to import our vectors parameter, right? Let's import our vector parameters. We're going to make use of that, right? So we have from Qdrant client dot http dot modules import distance and vector. So because we're going to create our vector config, so we have vector config, which is vector params, size is 3072. So vector params is basically a way to implement the dimensions, to configure the dimension of the vectors. So like we have the size now. The size of this basically matches the text embedded tree large. The text embedded tree large makes use of the size of 3072. So whatever embedding system or instance you're using, the size must match the vector parameter size. And then we have the distance, which is distance dot cosine. So we're making use of cosine to calculate the similarity, between the retriever and the stored vectors. So yeah, I already explained what the vectors form is all about in my previous video. Good, we've created our collection. Now, next thing we're going to do is to create an instance of our vector store. So we need to import our vector store, right? And then we'll do from Langchain Qdrant, import Qdrant vector store, and then we'll make use of that. Qdrant vector store is equal to Qdrant vector store. So we pass client, pass our client, our Qdrant client, our collection name, pass our collection name, and then we'll pass our embedding. So it's going to take some time, okay, and now we're done. So now let's add our document. Now that we've created the instance of our vector and we've created our collection, so the next thing we're going to do is to add our document to the vector database. And we're going to make use of the instance of the Qdrant vector store to do that. So we can see that we pass 3 parameters: the Qdrant client, which is going to communicate, used to communicate with the Qdrant host. Then we pass our collection name, and then our embeddings, which is going to use to convert the text into vectors, and then to retrieve the top most relevant context for our question or for our query. So let's add our document to the store. So we are creating our knowledge base using the vector store. So we'll add that. So it's going to convert this document into vector and store it into vector store. So we can see that we pass the embedding there. The embedding is the one that is going to do the conversion, to convert the document into vectors and save it into the vector database. So let's do that. Dot add document. You can see that we're adding our chunks. These are our chunks. So we're not adding the whole file. Instead, we're adding the chunks, right? Which makes it easier. Knowledge text. Let's see. So you can see that this is, if you count this, you know that we have 10. So this is the ID of each of the documents, each of the chunk that has been added. And if we count this, we'll see that it matches the length of the knowledge text. So yeah, we've added our documents. The next thing we are going to do is to create our retriever. Our retriever is going to filter through the Qdrant vector database and retrieve our knowledge base whenever we request for it. Right? So let's create our retriever. So we'll do retriever Qdrant vector store dot as retriever search parameter, search type rather. So we are searching for similarity. So we are checking for similarity, and the search keywords argument, which is K, which is a top 4. So this K means the top K relevant documents. It's going to convert our query to vector store and then sift through all the documents and calculate which of the document matches our query, and then it will retrieve the top K. Here our K is 4, so it's going to retrieve the top 4 documents that matches our query. So we've done this. We've created our retriever. So Let's create an instance of our prompt, our LLM. So let's import OpenAI. Langchain, OpenAI, import chat, open AI. So we're here, and then we can create our LLM to be chat, open AI, and we can pass a module to use the version of, so we can use GPT 3.5. Great. So the next thing we need to do is to create our prompt. So this is a bit of prompt engineering. So let's go. Let's try with you are an assistant that only answer question based on the provided context. So I'm going to use the multi-line because I don't want it to extend to the limit of the view. If you do not know the answer, say exactly that you don't know. Use 3 sentences maximum. Keep the answer concise. So let's pass the context. 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 So that's our prompt. Our system prompt. So let's create our prompt for message that we're going to pass into the system. So let's import the chat prompt template. So do from Langchain call.prompt import chat prompt template. So we can do prompt is chat prompt template dot from messages let's create the list system prompt email. So this way we're going to pass our input. So we created our prompt. Now so the next thing we're going to do is to put all of this together, and we're going to create a chain, right? Basically we call it a RAG chain. So we put all these prompts, the system prompt, which is already embedded in the prompt, and then we put prompt, and then we create a pipeline, right, that we're going to pass the prompt to. We're going to make use of two packages. And so let me import the packages. So we have from Langchain dot chain dot combine document import create stuff document chain. That's then the other one from Langchain import create retriever chain. So let's pass our question answer. Let's create our question answer chain. So create stuff document so pass our LLM, our prompt, and then create our RAG chain. Create retriever chain. So pass our retriever and then our question answer chain. So let's create a query or question. Let's name it query. So what question can we ask it? What is the concern with the use of AI? So basically, this knowledge base is basically talking about the synthetic knowledge and crisis of digital trust using AI, where AI can try to manipulate and control information while trying to be relevant, right? Instead of providing trust and credibility. So that's exactly what this blog post is all about. So if we ask it question based on that, right, you can see that this document is on my local, but I'm asking the question based on this information that I have on my local, right? So let's see what it's going to do. Here's the results. Invoke. Can do results answer. Yeah, you can see that bring the context that is relevant to that file. So let's ask it another question that is not in the document, like what is my date of birth? And we should see, should tell me it doesn't know. Yes, exactly. So because it doesn't have access to that. It doesn't know my date of birth. It only knows the information I passed through it, which is part of the knowledge base. Right. If I want it to know my date of birth, all I have to do is to create a document that has all the information about my date of birth, my year, the month. Then I'll pass it into the vector store, and then it can retrieve that information from there. So that's the only way it can know my date of birth. So for now, it doesn't have access to that. So it doesn't know. The only thing it knows is basically the context of the content in the file that you trained it with. So basically this is AI. You can create a lot of your custom or domain specific knowledge and you can train it with it, and yeah, it should be able to retrieve those information for you. So thank you for this video. So if you have any question or any concern, you can drop it in the comment section and I will answer you. Thank you. Bye.